Oh, I found you. I've been looking everywhere for you. Anyways, welcome to Math Expressions! Yay! The place where math weaves abstract concepts. Start, or just a program where children learn math. Grades K to 6, you know. Anyways, we're going to read this family letter that's going to talk about what we're going to learn about today. Dear family, your child has experience with fractions through measurements and in previous grades. Unit 6 of Math Expressions builds on this experience. The main goals of this unit are to understand the meaning of fractions, compare unit fractions, add and subtract fractions, and mix numbers with like denominators, and to multiply a fraction by a whole number. Your child will use fraction bars and fraction strips to gain a visual and conceptual understanding of fractions as parts of a whole. Later, your child will use these models to add and subtract fractions and to convert between fractions equal to or greater than 1 and mixed numbers. Examples of fraction bar modeling. These are the fraction comparisons, and this is the fraction subtraction. So, when we look at 1/3 of this rectangle and 1/2 of this rectangle, 1/2 is a further distance, but 1/3 is a shorter distance. So we could say that 1/3 is less than 1/2. Really, these blocks that are shaded in gray are bigger. So that means that the fraction with the smaller denominator is greater than the other one with the bigger denominator. I know, right? Then there's fraction subtraction, where your child will learn how to subtract fractions, even in the real world. So this is 5/5 or 1 whole rectangle. But just imagine if you crossed out 2/5 of the rectangle. Do you know how 5 minus 2 equals 3? Well, that's it. You do not subtract 5 minus 5. You just have to leave it exactly the same. So it will not equal 3 0/5 because there is no thing as a 0/5. So don't subtract the 5 minus 5. Just let the denominator stay the same because it's still fifths, not 0/5, so that your child will not get confused between fraction subtraction and fraction comparisons. Your child will apply this knowledge about fractions and fraction operations to solve real-world problems. If you have questions or problems, please contact me. Sincerely, your child's teacher. All right. My other friends, squid, shrimp, and crab, are going to come here in a second. So, while we wait for them, we don't want to read this in Spanish. That's too ridiculous. We cannot speak in Spanish. But while my friends are coming here, let's learn a couple vocabulary words together. What vocabulary words do you see? Yep, that's correct. Denominator, fraction, mixed number, numerator, and unit fraction. Let's learn together. What is the denominator? Pronounce it with me. Denominator. 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 Oh, that's a tongue twister of it. But good job pronouncing that. Now, what is a denominator? The denominator is the number below the bar in a fraction. It shows the total number of equal parts in the whole. In the fraction 3/4, we can see that 4 is the denominator, indicating that the rectangle is split into 4 equal parts. That's what the denominator stands for. Now let's chunk this word. Fraction. Fraction. What is a fraction? A fraction is a number that is the sum of unit fractions, each an equal part of a set or part of a whole. Examples of fractions are 3/4 and 5/4. 3 equals 1 plus 1 plus 1, and 5 equals 1 plus 1 plus 1 plus 1 plus 1. But besides that, 3/4 equals 1/4 plus 1/4 plus 1/4, and 5/4 equals 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4. So it's the same thing if you go back to kindergarten and learn that 3 equals 1 plus 1 plus 1. The only difference is the denominator. You have to say 3/4 equals 1/4 plus 1/4 plus 1/4 instead of saying 3 equals 1 plus 1 plus 1. Use that strategy in kindergarten to help. Anyways, mixed number. I think we should already know how to pronounce this already. But anyways, what is a mixed number? Is it a number that's mixed? Of course not. That's why we're flipping the page and learning what it is. Anyways, a mixed number is a number that can be represented by a whole number and a fraction. Examples of mixed numbers are 4 and 1/2, 2 and 1/2, even 3 and 1/4, etc. 4 and 1/2 equals 4 plus 1/2. Think about it. 1/2 of a rectangle is indicating that a rectangle is separated into 2 equal parts. But what if you add 1 more half to 1/2? That would equal a whole. So that's 2 parts, and 2 parts of 1/2 equal a whole. So that's why 1/2 plus 1/2 equals 1. Easy peasy lemon squeezy. Numerator. What is a numerator? Is it a rater that contributes numbers? No, of course not. That's silly. Anyways, the numerator is the number above the bar in a fraction. It shows the number of equal parts. Examples of numerators are 3, 4, etc. Any whole number at the top of a fraction is a numerator. It shows the number of equal parts. 3/4 equals 1/4 plus 1/4 plus 1/4. The numerator shows that the rectangle is broken into The 4 indicates that the rectangle is broken into 4 equal parts. I'm sorry. And then the 3 indicates how many parts of the rectangle are shaded of the 4 equal parts. Sorry, teaching difficulties. I'm terribly sorry. So anyways, this is the unit fraction. What's a unit fraction? Well, a unit fraction is a fraction whose numerator is 1. It shows 1 equal part of a whole. So, if the numerator is 1, and if the denominator is 4, 3, 2, or any other whole number, it shows only 1 part of the 4 parts shaded. So that's why a unit fraction could have a numerator of 1. And that's it. I think we're done learning about the vocabulary words. Nice job, everyone. Whee! Coming through. Watch out. Oh, sorry, fish. It's okay, squid. Anyways, my name is Fish, if you haven't noticed. And these are my friends. Squid. Hello. Shrimp. How do you do? And crab. Ow! Anyways, these guys are here to learn about fractions. What? Fractions? Darn. What are fractions? That's a really good question. Unit 6, Lesson 1. Understand fractions. fractions. So, we are going to understand what fractions are, and we are going to try a couple fraction problems ourselves. Do you think we can handle this? I don't know. Can we? Of course we can, because learning makes us smarter. Oh, yes, of course. All right. Sums of fractions. And before we start, we could see that Lizard, hi Lizard. Oh, hi Fish. Lizard has our vocabulary box that we talked about. But mixed number is not in there, probably because we have to finish this lesson and all the other lessons that talk about only fractions first. Then we can learn about mixed numbers. So, Lizard, can you give us all your vocabulary words in your vocabulary box? Yes, of course. My vocabulary words are unit fraction, fraction, numerator, and denominator. Very nice. Very good. And speaking of vocabulary words, I think the first paragraph already has one highlighted in yellow. That's handy. A unit fraction represents one equal part of a whole. A unit fraction has a numerator of 1. The unit fraction 1 over d is one of d equal parts. What is d? D is a variable. We could substitute any whole number for d to be the denominator. Let's say that d equals 4. Then the unit fraction will be 1/4. Let's say d equals, 2. Then the unit fraction will be 1/2. Let's say d equals 10. The unit fraction will be 1/10. Oh, that makes sense. The fraction bar below is divided into 6 equal parts, or sixths. Each part is one of 6 equal parts, or 1/6. So, as you can see here, to double check, we could count all of the separated parts in this very long rectangle. Excuse me again. Sorry. Anyways, as I was saying, 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. So we could see that if you ended up with 6/6, you know that the rectangle is divided into 6 equal parts. Each part is one of 6 equal parts, or 1/6 of the rectangle. So you could double check that to make sure, but I don't think they have made any errors. A fraction is the sum of unit fractions. The fraction n over d is the sum of n copies of 1 over d. Wait, what? Let me make it easier. In other words, n equals numerator and d equals denominator. N indicates the number of unit fractions in the fraction, and d indicates the number of equal parts in the whole. Oh, that makes a lot more sense now. Yes, number of unit fractions in the fraction is what the numerator means, and the number of equal parts in the whole is what a denominator means. So, this would pretty much make sense. And they have got little arrows to point to the right variables and show you. It kind of makes sense because numerator begins with n and denominator begins with d. So n and d are probably the best letters to use. Oh, yeah. Very interesting. I would like to learn more. Okay. The fraction 5/6 is the sum of 5 1/6 unit fractions. Huh? But wait, 5/6 and 1/6 are two completely different fractions. How is that even possible? It's 5/6. Like, for example, 5/6 equals 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6. If you count the sixths, 1, 2, 3, 4, 5, there will be 5 1/6 unit fractions. Oh, I see it now. Yes, I'm still a bit confused, but I think I understand some of the topic. Very good, Crab. And then 5/6, believe it or not, is equivalent to 5 times 1/6. What? How is that possible? Let me teach you, Squid. Do not worry, I'll explain it to all of you guys. Chaw! You know how 5 times 1 equals 5? Uh-huh. Well, 5 whole parts equals 5. So we could draw a bar and the number 1 to substitute it. 1 times 6 is 6, and 5 times 1 is 5. So that would be equivalent to 5/6. Or, without doing the bar and the 1, you could leave 5 as a whole number. 5 times 1 is 5, and then drop down the bar and the 6. That would also be equivalent to 5/6. Ooh, so interesting. It is interesting. Look, this fraction bar shows a really big blue rectangle, but it only shows the parts that are shaded, like 5/6 out of 6/6, or 1 whole. Fold your fraction strips to show each sum of unit fractions. We're skipping that part. We don't have enough time for that. Write the fraction each sum represents. So it's really easy. What is 1 plus 1? 2. The denominators have to stay the same. So what is 1/3 plus 1/3? Would that be 2/3? That's right, because the denominator has to stay the same. Don't do 3 plus 3. Only do 1 plus 1 and let the denominator stay 3, because it's not sixths, it's thirds that we are talking about. So that's why you are not supposed to add the denominators unless they're unlike, which we'll talk about next. Anyways, let's go to number 2. How many eighths do you see? Let's count. 1, 2, 3, 4, 5. Okay, well, the denominator has to stay the same. So it cannot be 5/8 added together. So it has to stay 8. So what is 1 plus 1 plus 1 plus 1 plus 1? 5. And what is 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8? And that would obviously be 5/8, because 8 needs to stay the same. It's not changing its value. Only the numerator is changing number. So you have to add the 1s, not the 8s. You have to leave the 8s and add the 1s. I think it makes a lot more sense now. It's not like 5/8 parts. Do you agree? Yeah. I don't think we should add the 8s. I think we should add the 1s. Same. Yeah, I think so too. Oh my goodness. This one's kind of interesting. Problem number 3 is related to problem number 1, only the denominators are different. But don't worry, that doesn't change anything, because we know that 1 plus 1 is 2, and the 4 has to stay the same. So either way, even if the denominator has changed from 3 to 4, but the numerator is still 1, then it doesn't make any difference at all, because we know that 1 plus 1 is 2, and then we have to leave 4. So it's 2/4. 2/3, 2/4. Completely different sums, but still really correct. Yeah, so 2/4. Let's kind of talk about 2/4 for a second. All right. Without me helping you, what do you think 2/4 in simplest form is? Huh? Go discuss about it. Okay, so okay, 2/4 equals 2 divided by 4, right? 4 divided by 2 is 2, but what is 2 divided by 4? I don't know. Oh, I think it might be greater than 0 and less than 1. Somewhere between 0 and 1. What is the fraction between 0 and 1? 1/2. Oh yeah, 1/2. That's it. Fish, we have figured it out. What is it? Is it 1/2? That is right. Because if you think about it, 2 times 2 is 4, and 1 times 2 is 2. Or you could think about it as a division problem. 2 divided by 4. Well, 4 divided by 2 is 2, so 2 divided by 4 must be 1/2. 1/2. Yes, I think that's the correct answer. It is. Alrighty now. So how many 6ths do you see? Let's count them together. 1, 2, 3, 4. So that means 4 6ths. I think these are starting to get pretty easy now. But we are only beginning half of it. Now we are going to make the difficulty level even higher. Whoa, that's a lot of 1/12. 1/12, 1/12, 1/12, 1/12. Oh, okay, I give up. How many 12ths are there? I don't know. Let's count. 1, 2, 3, 4, 5, and 6. There's no more. So that means it's 6/12. That's right, Squid. It's 6/12. 6 times 2 is 12, and 1 times 2 is 2. What do you notice? That's equivalent to 1/2 too. Oh my goodness! And if you think about it, 6 divided by 3 equals 2, and then 12 divided by 3 is 4, so it's equivalent to 2/4 as well, which is equivalent to 1/2. Oh my goodness, fractions are amazing! They sure are. Now, the denominator is the same. It still has 12, but now there is a little bit more. Whoa, look at all these 12ths. Let's count them together. 1, 2, 3, 4, 5, 6, 7, 8. 8 12ths. We could simplify any fraction. So 8 divided by 2 equals 4. And then 12 divided by 2 is 6. So it would be equivalent to 4 6ths. Whoa! Oh my goodness! Oh my goodness indeed. Then if we count up these eighths, 1, 2, 3, 4, 5, 6, 7, we could see that it's equivalent to 7/8. This is starting to get really easy now. Yes, it is. But now we are going to turn to the next page. Patterns in fraction bars. Huh? Wow, this is very interesting. It sure is, Crab. Now, let's move on to this next page. And let's do this one together. We don't have to write it down, but at least answer it in your own words. Describe at least 3 patterns you see in the fraction bars below. I will give you 1 minute to see at least 3 patterns in these fraction bars. Think about it. 1 equals 1 whole. 1 divided by 1 is 1. And then 1 equals 1 whole. 1 equals 1 divided by 1. That's nice. And then any number divided by itself is 1. So these fractions that have the same numerator and the same denominator only equal 1. So all of these equal 1. So now, with your partner, Describe at least 3 patterns you see in the fraction bars below. And go! Wow, I love seeing all this chitter chatter. Keep talking. I think you might be right. Possible. Keep talking. Oh, I just love to see you talk. Sorry, I won't disturb you again. Keep talking. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Timer is up. Now, the answers may vary, and I mean a lot, depending on these fraction bars. One pattern that I see is when we trace the 1 down, 1/2, 2/4, 3/6, 4/8, 5/10, and 6/12 traced on the 1 line. Do you see? So, that would be equivalent to 1/2 of the whole bar. And another pattern that I see is that 1/4 is 1/4 of the 4 equal parts. And it kind of makes sense. Because if you think about it, 4/12 is 1/3 of the 12s. But 1, 2, 3/12 is 1/4 of the 12s. So that's another pattern you might see. And then the third pattern I saw is when we trace the 1, look, 1.5 over 3. So 1 and 1/2 over 3. That's not really a real fraction though. But 1 and 1/2 of a third is equivalent to 1/2 of a whole. So that might be something that we could learn another time. So anyways, nice job everyone. Sorry if I did not get to all of your patterns that you noticed, but I was just trying to come up with the 3 main patterns that we all should see. Anyways, let's keep going. Exercise 9 has already been done for you. 3/4 equals 1/4 plus 1/4 plus 1/4, which is equivalent to 3 times 1/4. So that means that for exercise 10, 3/8 equals 1/8 plus 1/8 plus 1/8, and that is equivalent to 3 times 1/8. And we could shade 3/8 to show that. And for 3/4, we could shade 3 of the 4ths. See? But what about 5/5? Well, you know how I said any number divided by itself equals 1? So 5/5 is equivalent to 1. Very interesting, huh? So we shade the entire bar because it's one whole bar. It's 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5, which is 5 times 1/5. All of these other ones kind of make sense because we would have to shade and then multiply by the numbers to show that sum of unit fractions. That's very interesting to learn. All right, now let's go to the next page. Fractions as parts of a whole. We are going to skip these questions, and we are just going to read this sandwich scenario, okay? So don't worry about the questions, just worry about this. John made a large sandwich for the 6 people in his family. He asked his father to help him cut it into 6 equal pieces. To do this, they made a paper cutting guide that is as long as the sandwich. John folded the paper into 6 equal parts, and his father used it to cut the sandwich into equal pieces. So, you see the sandwich? The sandwich is here, and the folding paper is here. Let's count to make sure. 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. So we could see that it's divided into 6ths, or 6 equal parts of the whole. So the sandwich is just as long as the folding paper. You just can't see the lines separated in the sandwich because it's as long as the separating paper. Nice job! Next, we are going to talk about fractions that add to 1. That add to 1? But fractions are less than 1. How could that be possible? Well, not all fractions are less than 1. Some are greater than 1, like 5/1 or 5/5. Oh yeah, sorry. 5 divided by 1 is 5, and here's 1 whole. 5 divided by 5 is 1, which equals 1 divided by 1. So it's 1. So on these bars, we could see a scenario. Fifths that add to 1. Let's read the scenario together. Every afternoon, student volunteers help the school librarian put returned books back on the shelves. The librarian puts the books in equal piles on a cart. One day, Jean and Maria found 5 equal piles on the return cart. They knew there were different ways they could share the job of reshelving the books. They drew fraction bars to help them find all the possibilities. So you see, that's why these fractions and fraction bars are here. 1 whole equals all of the books, or the whole section of books. This is 1 whole, which is 5/5, or 5 divided by 5, which equals 1, which equals 1 whole, which equals 1 divided by 1. This section is Jean's share, and this is Maria's share. This is not required, but if you want to on your workbook, you could write total. But it's the same thing as 1 whole. So this is not required, but if you just want to, you can write total. This is optional. You can write total or not write total. It's fine with me. You could write 1 whole. I don't care, because 5/5 is equivalent to 1 whole. And let's just keep going. 2 plus 3 is 5. 3 plus 2 is 5. 4 plus 1 is 5. And 1 plus 4 is 5. Don't add the 5s. Just add the numbers that equal 5, and you would get 5/5. Yes, I could see patterns. 2, 3, 3, 2, 4, 1, 1, 5. I mean, not 1, 5. 1, 4. Sorry, I messed up. It's okay. Sometimes rushing can give you wrong answers. That's why we always tell you not to rush just to get something done. You need to take your time, and even if you don't finish, that's okay. You could do it for homework. Easy peasy, lemon squeezy solution. Anyways, here's something interesting. Find the unknown addend. Write the fraction that will complete each equation. So 1. Wait, there is a 1? Yes, there is a 1. I love the number 1. In fact, it's one of my favorite numbers. Get it? One of my favorite numbers. One of... Let's continue. 1 equals 7/7, because 7 divided by 7 equals 1. 7/7 equals 1/7 plus 6/7. You want to know why? Because 1 plus 6 equals 7. Now I could see. Yes, and it's related to all of these problems over here. Just find these fraction addends and you'll be fine. You will complete these for homework in a breeze. Just because I told you, and now you've learned. Now, let's compare unit fractions. Wait, you can compare fractions? Of course you can, especially unit fractions. They're one of the easiest fractions to compare. Use these fraction bars to help you compare the unit fractions. Write greater than or less than. There are probably some fractions that are not equal to. But we could see here this repetitive pattern of 1. Same numerator, same denominator, automatically equals 1. And 1 equals 1 whole, just to get you with that teeny tiny little detail. So how we compare unit fractions? Well, let's look at 1/6 and 1/8. 1/8 is small and 1/6 is small too. But we could see that 1/6 is a teeny bit longer than 1/8. So that's how 1/6 is greater than 1/8. The fraction with the smaller denominator is bigger because these blocks stretch out longer than the smaller blocks can. So that's how we compare those. When comparing two unit fractions, the fraction with the smaller denominator is always greater. You have to know this to prepare for fractions in the real world, because if you do not know this, well, then you will not even know how to compare simple fractional numbers. So anyways, let's skip these and go to this one. Did you know that you can add fractions too? What? And you could subtract them. So, 3/7 plus 2/7 equals 3 plus 2 over 7 equals 5/7. 3 plus 2 over 7. Now that's an interesting fraction. It has 3 plus 2 as the numerator, an equation numerator, but 7 is the denominator. 3 plus 2. Well, that equals 5. So the numerator should already be simplified by that. That kind of really makes sense for the rest of these. What happens to the numerators in each equation? What happens to the denominators in each equation? Well, don't worry. Let me tell you. The numerators get inputted into the top part of the fraction, and then they're added to create a new numerator, like 3 plus 4 over 9 equals 7/9, because 3 plus 4 equals 7. But the denominators stay the same. They do not get added together. Like, for example, don't add 9 plus 9. Just add 3 plus 4 to get 7/9. Not to get 7/18, because 9 plus 9 is 18. I get it. But the denominators always have to stay the same. You cannot add them to make those fractions smaller. You have to add them. And subtracting them is pretty much the same thing. The numerators get subtracted together to create a new numerator. Like, for example, as we can see here, 4 minus 2 over 7 is 2 over 7 because 4 minus 2 is 2. But notice how the sevenths are exactly the same. That's because the denominators are not supposed to change their value. It's still sevenths. So it's not going to be 2 zeroths because 7 minus 7 equals 0. I get it. Any number subtracted by itself is 0, but that's only in kindergarten. In the fraction world, do not subtract 7 minus 7. Just subtract 4 minus 2 to get 2 sevenths, not 2 zeroths. This will help your little fourth graders tell the difference between adding and subtracting fractions. Alrighty. These fractions could be solved in horizontal form, but also in vertical form. And these parts are circled for you to include the circled step in exercises 16 to 21. So it kind of makes sense. This is the circle part because 4 plus 5 over 10 would equal 9/10. Same thing, just circle these. And that will be part of the fraction equation to help you solve it for your for you, for your knowledge of fractions. And then vertical form, well, it's the same thing. You just have to work on it on vertical positions. So it's pretty much the same thing. All right, Puzzled Penguin, what do you need help with? Phew, finally, Fish, you came here. I'm so relieved. Now, where am I? Oh, yes. Dear math students, my friend said if you catch 3 fish and then 2 more fish, how many fish will you have? Of course, I know I will have 5 fish because 3 plus 2 equals 5. She said this is the same problem, but you have fifths instead of fish. Can you help me understand what my friend meant and help me find the right answer? Your friend, Puzzled Penguin. A fraction problem. Puzzled Penguin wrote this fraction problem all by himself. 3/5 plus 2/5. And he wrote 5/10. Is that the correct answer? No, because what happens to the denominators in the equation? Right, the denominators have to stay the same. Do not add 5 plus 5. Just add 3 plus 2. And then that's it. You would get 5/5 or a whole of a fish. So it's not 5/10. It's 5/5. So don't add the denominators. They are supposed to stay the same. That's what your friend meant. The correct answer you are supposed to have written is 5/5, which equals 1. Oh, yeah. Thank you. Bye-bye. Bye, Puzzled Penguin. What? Puzzled Penguin? How did you get all the way here? Penguins can jump over 30 feet. However, they don't. What is your problem this time? Dear math students, my friend said my answer for this problem is wrong too. As I knew it. She said, think about fish again. If you have 4 fish and then eat 3, how many will you have? Well, I would have 1 fish. But what does she mean? What should the answer be? Your friend, Puzzled Penguin. Looks like the answer is totally wrong. You're right, Puzzled Penguin. The answer is wrong. Because you are not supposed to subtract the denominators as well. It's not 1/0th. Because you cannot divide by 0. Oh, 1 divided by 0 equals undefined. So I am wrong. That's right. 1/5 is the answer. Don't subtract the denominators too. Remember, the denominators are supposed to stay the same no matter if you're adding or subtracting. You must let the denominator stay the same no matter if you add, no matter if you subtract. You must follow that rule. Sorry. It's okay. At least you learned your lesson. Bye. Bye-bye. Finally, that Puzzled Penguin is gone. All right. Whoa! Oh my goodness! What is this? That's a good question, Shrimp. Well, I have one vocabulary word in my vocabulary box, if you haven't noticed. Mixed number. We're going to learn about mixed numbers. Yay! A mixed number is a number that consists of a whole number and a fraction? How is that even possible? Well, a fraction greater than 1 has a numerator greater than its denominator. So that's how these improper fractions, like these ones, 10/6 and 19/5, could be simplified to 1 4/6 and 3 4/5. Oh! Melly's Deli makes sandwiches. This is the price list. A regular serves 2, costs $3. A friendship is $5. A super is $12. And a magna is $20. 19 friends decide to buy lunch for their camping trip. They order 2 super sandwiches. each camper eats 1 serving. Okay, so let's look at the super column. If we follow the super column, we could see that it costs $12, but 19 friends want to order 2 super sandwiches. So 12 times 2, what is the answer? 24? That's right, and it serves 10 for 1 super. So that would be serves 20 if they want to order 2 super sandwiches. That means 2 supers, which serves 20, will cost over $24 for the 19 friends, and each camper eats 1 serving. So it's 1 out of the 20. Yes. But there could be times that 4th graders could confuse this and say 20 over 1. Or 24 over 1, as I should say. We should not do that, because 24 divided by 1 is 24. And 24 servings, well, it's not 24 servings, it's 20 servings, because we are ordering 2 supers 20. Because 1 super is 10, and 2 supers are 20. 10 times 2 is 20. So 24 servings will not make sense. So, let's turn to the next page. We'll skip this, and we will just move on to this. So we are going to understand fractions greater than 1 and mixed numbers. Ooh, what are these? These are fraction bars and strips. With the help of a grown-up, you can cut them off side to side and all around, so that you could understand fractions forever. And then, same thing. Adding is very simple too. Add plus 8 plus 3 is 11. Even though 11 fifths and 8 fifths are both improper, you don't have to simplify them. You could just do it as an improper fraction. That's really nice how they gave us that option to do that. And then, this is kind of the same thing. So, these methods can help you in the real world to add and subtract fractions greater than 1. What is it again? Oh, here we go again. Puzzle Penguin, what do you need help with? Oh, I'm so terribly sorry, but I do not know how to compare these mixed numbers. Can you help me? Of course. 3 and 2 fifths and 1 and 4 fifths. Well, here's a trick. You know how 3 is greater than 1? Yeah. So 3 and 2 fifths must be greater than 1 and 4 fifths. Ah. Yes. That is really cool. Thank you. You're welcome. Anytime. Any more? Nope. That's it. Okay. Bye, Puzzle Penguin. We'll see you another time. Okay, bye-bye. Bye. Finally, that Puzzle Penguin is totally gone. So, that's it for the fractions. If you feel like you're still confused, or if you feel like you need more learning, no problem. You can learn about fractions again. If you understand fractions really well, then you will be ready for advanced numeracy. Fractions are actually a good subject in mathematics, in middle school math, high school math, even when you get to college. Because as a banker, you need to find out what half of money is and what fourth is a money, etc. So, fractions are actually really helpful. Alright, you could find this Grade 4 Volume 2 book by searching up Math Expressions Grade 4 Volume 2. Just look for the book with the lemur in it with the green forest background and the HMH watermark, don't forget, and the NSF or National Science Foundation tag at the bottom of the page. And then if you want to double check, you can flip it over. The back of the book should have the lemur's bottom and its tail all the way like this. And then a couple more trees. The barcode, the idents, the math expressions title, and then there should be a lizard at the back. If you don't see a lizard, then your book might be broken or teared apart. But I'm pretty sure your book will not be teared out. At least if you take good care of it. And as usual, you should have the Houghton Mifflin Harcourt watermark, as well as how to find these books, hmhco.com. So you should have all those things. If you have all those details, or if your book has all these details, then this is your book. So that's it. What fraction facts did you find interesting? Let us know by giving us a like and subscribing to the channel. We have reached over 3.14 thousand subscribers, or just 3,000 subscribers. But thank you very much for giving us 3,000 subscribers. See you at 4,000. Wait, we're going to get 4,000 subscribers. Yes, eventually. Yay! I want Apple official channel to get more subscribers. Please subscribe, guys. Please subscribe. I can't wait. Bye. We'll see you again soon on Apple official channel. See you later. Have a great Memorial Day. Bye. Fraction bars are really helpful for 4th graders to learn about fractions. You can get this Grade 4 Volume 2 Math Expressions workbook at Math Expressions, the HMH watermark, and the National Science Foundation. Speaking of that, major support for Math Expressions is funded by the National Science Foundation. To find out about this book, this material is based upon work supported by the National Science Foundation up to great numbers ESI 9816320, REC 9806020, and RED 935373. Any opinions, findings, and conclusions or recommendations expressed in this material are those of the author and do not necessarily reflect the views of the National Science Foundation. Watch the lemur come alive in its forest as you discover and solve math challenges. Download the MathWorlds AR app available on Android or iOS devices on the App Store or Google Play. By Dr. Karen C. Fusion. Cover illustration, copyright symbol Josh Brill. Copyright symbol 2018 by Houghton Mifflin Harcourt Publishing Company. All rights reserved. No part of this work may be translated by anyway.